the branch of mathematics we're studying, calculus, was not developed or completed overnight or by one person. Calculus has been worked on for a very long time by very many people. And for that reason, we actually have multiple notations for the derivative. What we've seen so far is f prime of x, meaning the limit of the difference quotient, that derivative of f of x, the slope of a tangent line. Well, it's very natural then y prime would be the derivative of y, and f prime of x is the derivative of f, right? And those are common notations, and we'll see those a lot. Another notation for the derivative is this, df dx. What this tells me is literally this is the derivative of f with respect to x. And I'd like to tell you a little bit about why this notation is nice. So, if I revisit my difference quotient, what I have on top is the difference of two y values. That's the change in y, literally. On the bottom I have the distance between two x's. That's the change in x. After all, we started this conversation by thinking of the slope of a secant line. Slope is always the change in y over the change in x. All right, well, what I notice is delta x is literally h. So I could rethink my definition of derivative as simply delta y over delta x as delta x tends towards 0. The symbol we use for change is the Greek letter delta. And so one way to say that is, well, slope of a secant line I call delta y over delta x. By taking a limit, I get the derivative, which I will call df dx. It looks like a slope, right? It has that same look as the slope of a secant line. This notation is more similar to the notation that Wilhelm Gottfried Leibniz used. The body of work we're studying, the calculus, was first worked on by two mathematicians, Sir Isaac Newton, who you're probably very familiar with, and Gottfried Leibniz, who is a little less famous. Other ways of writing down the derivative, we could say this, d dx is literally a command that says take the derivative with respect to x and then of f of x. It's treating the derivative as an operator, right, as a set of instructions. This is telling me, hey, do the thing you call the derivative on the function f of x. This is less common notation, but your author mentions it, that you sometimes will see a capital D with a subscript x. It's like this one. It's saying, hey, take a derivative with respect to x of this particular function. And then the final notation we're going to talk about for right now is this, the derivative of f of x. This one you don't see a whole lot. These are the ones we'll see a lot in our course together, and this one might sneak in there every once in a while. All different ways of saying, hey, take a derivative. All right, we'll talk more about notation later on, but for right now, I feel pretty good about that.